Hi everyone, welcome to a Kuta worksheet tutorial on graphing linear inequalities. I am Mr. West and you are watching West Explains Best. Today we're going to sketch the graph of each linear inequality. Let's go ahead and jump right into this. Our first one, okay, so we have y is greater than or equal to negative 3x plus 4. What makes this different than your regular y equals mx plus b slope-intercept form? Well, it's because we're not using an equal sign here. We are using an inequality now, okay? That's why it's called a linear inequality. So it's still in the same form, though, and it's a very similar process to what we had before, so I'm going to give you the step-by-step breakdown. Step one, in my opinion, it's way easier if you do this. You need to get it into y equals mx plus b formed. Essentially, you want to solve for y, okay? That's your first step. Our first step is already done in example number 1. So ready to move on to number 2. Step 2. We want to identify boundary line. Okay, so we want to identify boundary line. Now, what does that mean? Well, what we're going to do here is we're going to look at this, okay, the inequality. If it is an inequality such as this or this, that's greater than or less than, we are going to use a dotted boundary line, okay? If it is greater than or equal to or less than or equal to, we are going to use a solid boundary line, okay? So just some differentiation there. Essentially what that means is with this guy, it can include the value that are right on the line, whereas with a dotted line, it can't include the value, okay? It has to be less than or greater than. It cannot be on the line. So that's what that means, okay? Step 3, and we're ready to move on to step 3, essentially, because we already recognize that this is going to be a solid line, okay? So step 3 for us, we are going to graph the line. Okay, since we're using a solid line, that's pretty good. Now, if you need a refresher on graphing slope-intercept form, that's the whole point of why we got it in this form in the first place, is because it's fairly easy to graph. I would recommend some of my other videos, but I'm going to go through it briefly here. And yeah, let me just talk about it. So the first thing we do is we look at the y-intercept. Y-intercept is the number by itself that doesn't have a variable. And we see that it's positive 4. Always look at the sign in front. And so we go to positive 4 on the y-axis to find that. Next up, we use our slope. Our slope in this case is the number in front of the coefficient of x. So it's negative 3. I like to consider it as negative 3 over 1. You can put any integer as a fraction by putting it over 1. And the negative 3 will be our rise, and the run will be 1. So if it's a negative 3 rise, oh, by the way, I make always my slope negative in the numerator. It just makes it a little bit easier to graph, in my opinion. So my rise is negative 3. That means I'm going to go down 3 units. And 1, 2, 3. I get to 1. And then I'm going to run. That's in the positive x direction. I always like moving left to right. Over to 1. Okay. And then I make another dot there. And there's my slope. Okay. So you basically graph the line by using plotting your y-intercept and then using the slope to find another point. You can repeat that process and find multiple points if you want. But that's the process for now, okay? We just need 2 points. So we graph the line. We're almost there. Now, I'd also recommend you graph your line. Sorry, I didn't go all the way. Don't graph your line like that. Don't graph it how I did. Go all the way across your graph, okay? And put arrows at either end. Now, step 4. This is the part that makes it different than just an equal sign. What we did right now is we just graphed y equals negative 3x plus 4. Okay, so we need to graph the inequality. How does this inequality change this picture? Well, we need to evaluate if it's y greater than, okay, or y greater than or equal to, or if it's y less than or y less than or equal to. If it's y's greater than, we will shade above the line. And if it's y is less than or y is less than or equal to, we will shade below the line. Okay, so we'll shade below versus shading above. Well, if you want to shave, that's your prerogative. That's your own hygiene issue. But we are shading here. Okay, now let's evaluate this. We have y is greater than or equal to. So we are going to shave, I keep saying it, Shade above the line. Now, a lot of students mix this up, especially when it starts getting like really steep. They're like, oh, I don't know which one's above. How do you know which one's above? To find out which one's above, you can always just go to any point. In this case, the y-intercept's usually the easiest one to go to. Okay, and you just see, okay, where is there a point above this? Well, there's a point above right here, right here. Okay, those are all points above. So we're going to shade, notice how I said shade this time. We're going to shade everything on that side of the line. Okay, we're going to shade above the line since the 0.05 was above. Sorry, I'm really picky with this. Since 0.5 was a point above the line, we're just going to shade. What's my shave count? I think I have a 3 shave count here. So kind of ugly there, but that's the solution. Now, why is this different than just the line? Well, because all these points, for example, let's take one of these points. All these points represent places that make this a true statement, okay? For example, if we were to test the point 3, 1, okay, that's 3 for the x, that's 1 for the y. Okay, let's test this point. You don't have to do this I'm just showing you why this works and what this means, okay? So I'm going to plug in 1 for my y. I'm taking this equation, I'm just plugging it in here. 1 for the y, 3 for the x, and then I'm going to see what happens here. Will this make a true statement? So I get 1 is greater than or equal to negative 3 times 3 is 9, or negative 9, plus 4. That gives me 1 is greater than or equal to negative 5. Is that a true statement? Yes, it is. That is a true statement. 1 is bigger than negative 5. So that is a part of our solution. If you were to test all these points all over the place on this side of the line, they're all true. What does that mean about the other side of the line? Let me show you, for example, let's use purple. This point here, that's 0, 0. That's one of the easiest points to test. You might have your teacher say such things as testing a point. That's what he's talking about, he or she. So we have y is, plugging in 0 for y. 0 is greater than or equal to negative 3 times 0 plus 4. So we get 0 is greater than or equal to 0 plus 4. We get 0 is greater than or equal to 4. Notice how this does not make a true statement. 0 is not bigger than 4. So that is wrong. So all these points on this side of the line are all non-solutions, okay? So that is why we have to include a shaded region, because it shows all the different places that make it true. All right, let's do a quick one, okay? So number 2 is kind of a quick one. We're going to follow the 1 through 3, 4 step process. So the first thing is it's already solved for y. Identify our boundary line. We know it's solid already because it's less than or equal to. Now we can graph the line. So we started at y-intercept, negative 5, up 3 over 5 for our slope. That makes a line like this, and we already know we're making it solid, and we're going from one side of the graph to the other. Okay, I know it didn't make it straight. Ugh, I can't help it. I got to redraw it. I'm a little OCD when it comes to this stuff. All right. Up 3 over 5, good to go. Now we have to determine which way we are shading. Well, look here. It's y is less than. So if you want to take my word for it, fine. If you want to test some points, that's fine too. But I'm just saying it's going to save you some time to go y is less than and graph everywhere below the line. Okay, and that's what your graph should look like. You should recognize this one. Okay, this one, this is a great one because a couple things. One, it doesn't look like it has a slope. It does have a slope. The slope is 0. So we could rewrite this in this form if you wanted, like that. But if you already know how to graph this one, okay, I'll show you how that works. Identify the boundary line. It's greater than, no equal to, so we're going to use a dotted line. I think, can I make a dotted line here? I forgot how to make a dotted line. I think I just got to go like this. So y is less than 4, so I'm going to make a dotted line on y negative 4. That's my 0 slope. Okay. And then it's greater than, so I'm going to be shading above the line. So I'm going to go above the line here. Make sure to make the sound effects as you draw it. Okay. Y is greater than negative x minus 5. Okay. For this one, I'm just going to give a hint. Okay, and then you can graph the rest. This is a negative 1 slope, so negative 1 over 1. Make sure you use that. Okay, all these ones are pretty standard. Aha, here we go. Now, look here. Step 1 is not done for, so guess what we need to do? We need to solve first for y. So we're going to subtract 5x from both sides. we're going to negative 3y is less than or equal to negative 15 minus 5x. This is a great problem, and I'll show you why. We need to divide by negative 3. If we divide by negative 3 to both sides, an alarm should be going off in our heads. We have an issue, negative, negative. We have to flip the sign. So we are going to flip the sign here, and we have y is greater than negative 15 divided by negative 3. We have to divide by both terms. We get positive 5, and then positive 5 over 3x, and we're done. Now we're ready to proceed. We know we're going to be using a solid line. Okay, and we can go ahead and use our y-intercept. That's 5. Our slope is 5 over 3. Ooh, I like this problem even more. More and more. I guess I'll use this color still. Okay, now if we go up 5 and over 3, guess what? It's off the graph, so you can go in reverse. 5 over 3 is equal to negative 5 over negative 3. So we can go in the negative y direction, down 5, okay, or rise of negative 5 is down 5. And then we can go the negative x direction. So that's a left 3. So 1, 2, 3, that would take us here, okay? So down 5, 1, 2, 3, 4, 5, and then 1, 2, 3 in the negative x direction, okay? So that's how you go backwards graphing. Draw our line, have it go all the way through, close enough. Okay, and now it's y is greater than, notice this designation here, y is greater than, so we're graphing above, or shading above the line. I didn't say shaving that time, how about that? Okay, that's how you do all these problems. Hope you found this helpful and that it is useful for you. One more tip, this is a vertical line here with an undefined slope, so just keep that in mind. Actually, we should do this one real fast. So our vertical slope is going to look like this, but it's a less than, not equal to, so we need to make it a dotted line. Okay, so this is a dotted line. The last thing, we want the values that are less than negative 5 for x, so we're going to graph to the left. If it's less than or less than or equal to, we graph to the left. If it's greater than or greater than or equal to, we graph to the right. That is only for x equals some number vertical lines. So we're graphing to the left with this one. It would look like this, okay? Wow, I did like tons of problems there. You should be almost done with this after you're done with this tutorial. I hope you enjoyed it. Thank you so much for watching.